Assalamualaikum students, welcome to Daily Physics Lecture 9. In the past 2 days, we were discussing about Kirchhoff's law. Yesterday, we discussed about single loop problem. We were discussing about single loop problem, and today I'm going to discuss about multiple loop problems. So here you can see that this is a circuit, and here this is not a single loop circuit. Here we have 1, 2, and the whole one, 3 loops. Okay, one and here this is the one small loop, 2, and the whole one, 3 loops here. So how we will solve this circuit? How we will solve this circuit? So before that, let me discuss about these steps. We already know about the first step, second step, third step, which are applicable for all the problems, and there are another 2 steps, and these 2 steps are just using junction law and using the Kirchhoff's second or loop law. So let's start with the first step. Name the points. So let's name these points: A, B, C, D, E, F. So I have already named the points. Now, how many junctions do we have here? So those who already watched the lecture, you already know that A, C, D and F, these are not junctions. Here the junctions are B and E. So these 2 are junctions. And how many lines do we have? We have here junction to junction. Line means junction to one junction to another junction. So from BAFE, this is one line. B to E, this is other line, and BCDE, this is the third line. So there are 1, 2, 3 lines. So there must be 3 current flow. And now, how many loops are here? So 1 loop, 2 loop, and the whole 3 loop. So let me write it. So here the loops are, if I start from B, B, A, F, E, B. So this is one loop. Loop will start from a point and it will end at that point. Line and loop are different. Line will start from one junction and it will end at other junction. But loop will start from one point and it will end at that point. So BAFEB, that is BAFEB. So this is one loop. Okay, here BCDEB, that's the other loop. And we have the third loop, which is ACDFA, that is the whole loop. So there are 3 loops. Now the problem is that we don't actually know how many lines we have to go through or how many loops we have to use. We can use the junction law because we have 2 junctions here, B and E. So now, what about the second step? Assume current flow through lines. While solving a circuit by using Kirchhoff's law, you have to assume 2 things. You have to assume 2 things. And these 2 things are in step 2 and in step 3. In step 2, you have to assume current flow through lines. How many lines do you have? It's not a factor, but as there are lines, so there will be current flows, and you have to assume the direction of current flow. As you don't know the current flow, you don't know the value, you don't know the direction, but you have to assume it. Okay, so let's start the assumption of current flow. Here, BAFE, this is one line, and here we have 1 and 2. So let's assume. So I assume the direction of current flow as clockwise. and suppose I denote it as I1. So from E to B, from E to B, this is one line, right? B to E or E to B, this is one line, and I assume the direction of current flow from E to B. Okay, E to B, that's I1. This is my assumption. Okay, what is the another line? B. B to E, and the third line B, C, D, E. Okay, so let's assume B, C, D, E. Through this line, the current flow is, suppose again, I assume the direction as anti-clockwise. Okay, it's all about my assumption. You can assume it clockwise. It's not factor, and I name it as I2. So this is I2 and this is I2. So through B, C, D, E, that means this line, that means if this line, I assume direction as anti-clockwise. Look, E to B and B, E to B, and through E, F, A, B, I assume direction as clockwise. Okay, and now this is the third line, which is BE, and through this third line. So now if we have only three lines, okay, and we have already completed our assumption through two lines, and now we have one line left, then it's better to weigh pragmatic. Why? Now if I reach here, you can see that at point B, I2 I2 current is moving inward, and at point B, I1 current is also moving inward. So here at point B, two currents are inward according to my assumption, right? I1 is inward and I2 is inward. Two currents are moving inward according to my assumption. So as we do know from the junction law, that all will move in, it's not possible. So some will move in, some will move out. So as these two are moving inward and we have one line left, so through this line the current should be outward. Let's assume it's I3. So the current flow through B to E, this is I3. So we have assumed three current flows and it's okay. Through B, C, D, E, the current is moving anti-clockwise, E, D, C, B path. Through this path, the current is moving clockwise and it's I1, E, F, A, B. And through this middle line, this current will flow from top to bottom. That means it's clockwise. Okay, you know that if the current flows like this, so it's from B to E, and through this middle point, the current is moving through B to E as I3. So I have assumed three current flow through three lines. So I have completed step 2. Step 1 complete, step 2 complete. As I said, we have to go for two assumptions. So assumption number 3, default positive or negative. So it's, as we have seen the problem in the previous class, we have to go for a default positive direction. It may be clockwise, it may be anti-clockwise. So here, so let me assume your current flow may have arbitrary direction, as we have clockwise direction in this line and anti-clockwise direction in this line. It doesn't matter. Current flow, the assumption of current flow may be different. The assumption of current flow may be different, but your default positive should be same for all loop. So here, default positive, we have this 2 loop and this whole damn 3 loop. So let's assume a direction as positive, either clock or anti-clock. So let's assume clockwise is positive. So here in this small loop, I assume clockwise as positive, and for this loop I have to assume clockwise as positive. So through all loop the clockwise direction will be positive. You can assume current in different direction, but you have to take your default positive through one direction, either clockwise or anti-clockwise. Okay, so we are done with this, and we have completed the assumption number 3, step number 3, and assumption number 2. So 1, 2, 3 complete. Now use the junction law. So here in this circuit, you have to use one junction. Let me use it first. How many junctions do we have? 2. So use one junction, okay? So we use B. At junction B. So here at B, what is junction law? I in = I out. That means total in is equals to total out. So how many currents are moving in here? Look, I1 is moving in and I2 is moving in. I1 is moving in and I2, this is moving in. So 2 currents are moving in. And I3 is moving out through this BE line. I3 is moving out. So total out is 1. So basically I3 is I1 plus I2. So if we can get I1 and I2, we can easily get I3. Okay, so that's equation number 1. So let's write it somewhere here. That's equation 1. So let's erase it. We are done with step 4. So let's use the step 5. Summation of E is equals to summation of IR. So now, as I already told that, we need to get I1 and I2 for I3. So our main task is to get now I1 and I2. So for this 2 current, we need two equations. And we can get those 2 equations from step 5. So here, as we need 2 equations for I1 and I2. 2 equations for I1 and I2. So we have to use 2 loop. Okay, so we have to use this step 5 twice. Now, there is something, a trick I want to discuss about. We have 3 loops, right? We have this small loop, and this whole loop. We have 3 loops, but we need 2 loops for 2 equations to get 2 current, I1 and I2. But we have 3 loops, so from this 3 loops, we have to get 2 loops. So which 2 we will choose? That's the trick. So let's see this circuit again and see the lines. Is there any line where no resistance is present? Let me say it again. Is there any line where no resistance is present? If is there any line, then try to figure it out. Okay, from B to E, we have 6 over here. So through this line we have 1 resistance. So this line contains resistance. From B to E, that is B, C, D, E. Here we have 2 resistance. One is 2 and another one is 10. So these line contain resistance. And from B to E, now here we have cell here, but we don't have resistance here. So now this is our line while we don't have any resistance. So we have got one line in our circuit which doesn't contain any resistance. So if you can find such a line, or if it's possible, then assume yourself lucky, because you have less things to do. So we have to use 2 loops from 3 loops, right? So let's use those 2 loops. Those are containing these line. So use to loop where we can have this BE line. If we take this loop BAFEB, this loop, it contains and if we choose BCDEB, this also contains, but if we take the total loop, that means the large loop ACDAFA, it doesn't contain BE line. So as BE line is a line which excludes resistance, so we have to choose two loops which contains BE line, and these two loops are these small two. Large loop doesn't contain BE line, so we will not use it. Let me remind you, we are choosing two loops because we need to use this second law of Kirchhoff twice to get two equation for two I1 and I2. We need two values, I1 and I2, that's why we need two equation, and for this two equation we have to use this loop law twice, and for using this loop law twice we need two loops, and we will use such two loops which contains BE line. Okay, and we got these two small loops. Okay, so we are going to use these two small loops. So let's use it. At first use this left loop BAFEB loop. So let's use this loop BAFEB, this loop, and we are about to use this equation. Step 5, Kirchhoff's second law, summation of E is equals to summation of IR. As I already told you that when you go through the left side of this equation, please forget that you have any resistance or any current flow through the circuit. Forget about the right things. I forget, R forget. Just deal with ease when you want to deal with the left side. So in this loop, our default positive is clockwise, and we have to get the E's, that means the EMFs. So let's find out cells. How many cells do we have in our loop? Forget about this thing. Okay, just forget it. E, F, A, B. Okay, forget about this thing. I am doing one thing to forget about this side. Okay. Why not put a cover here? So it makes it simpler. I am dealing with this loop. So here, B, A, F, E, we have 1, 2, 3 cells. How many cells? 3. So we have 3 EMF, 20, 10, 4. This is the part of this loop. So let's use the left side. This 20, this is plus, this is minus. This is plus, minus. So this cell is working towards this direction, right? Minus 2. We know current flows start from the positive side. So positive, so minus to plus. This is the direction of the EMF. So what is this direction? Is it clockwise or anti-clockwise? That's the loop, right? So if as I assume the clockwise is positive, so it means the hand of watch will move like this, right? So here, when the hand of this watch move like this, that means the clockwise positive direction, through 20, it will move like this. So 20 is acting along the direction of clockwise, right? From clockwise, so 20 is acting along the direction of clockwise. So 20 volt, that means the EMF of this cell is positive. 20 positive plus. Let's think about this 10. Now that's the positive, that's the negative. So the direction is like this. We know the direction will act toward the positive side. So now our default positive is clockwise, right? Look, that's our default positive. So anything works clockwise, we will assume that positive. But now here, this 10 is acting opposite. Look, that's our direction, and it is opposite to our direction of cell. The default positive is clockwise, but it is moving the other direction. Default positive clockwise, but it is moving the other direction, right? That's the direction of the cell, and that's the positive. That's the direction of the cell, and that's the positive clockwise direction. So this cell 10 ohm is acting anti-clockwise, so this should be negative. So minus 10. Now what about this 4? So for this 4 ohm, that's the positive and that's the negative. So this should be the direction of 4 ohm, right? This side is the negative side and this side is the positive. So negative, positive. So this is the direction of 4 ohm. Our default direction of this loop is clockwise, right? So through 4, now direction of 4 is opposite, right? Our clock's, the hand of the clock direction is this, right? Clockwise. But here the direction of the cell is anti-clockwise. So this 4 is not a positive cell. So it is the negative cell. Okay? So we are done with the EMF part, left side. Now we have the right side to deal with. What the right side is dealing with? I into R. So how many resistors here in the circuit? Only one. We don't have any resistance here, like. So we have only one resistance, and we have to deal with summation of IR. That means with this resistance we have to multiply the current 2. So the value of the resistance is 6, and the current which is moving through 6 is I1, right? So we have to put I1. Now we have to figure out whether this current is positive or negative. So now you can see that through this line, this is our assumed direction of current flow, which is this. Now we are dealing with the current flow, not the cell. Okay? So that's our I1. I1 is acting towards this direction. So this is our default clockwise direction. So I hope you can see that this I is now acting clockwise, right? Clockwise. Clockwise. This is the direction of I, and it is acting clockwise. It is acting clockwise. So I1 is positive current. So we need not to put positive sign here. So we have 3 cells, 2 are negative, this 10 and 4, opposite direction, and we have only one current, one resistance. So this I1 is a positive current because it is acting clockwise. So from this equation we can get I1. How? So let's simplify. 6I1, and this side, let's do it with the left side. 20 minus 10 minus 4, which means plus 6 is equals to 6I1. So I1 is equals to 1 ampere. We have got the value of I1 and it is positive. That means I1 is acting actually E to B. Okay, we got I1 as positive. That means I1 is acting from E to B. Our assumed direction from the second step was right. We have got I1, and I1 is equals to 1 ampere. Let's write it here. I1 is equals to 1 ampere. So let's go through the other loop. What is our other loop? This one. So let's try to cover this loop. And our other loop is B, C, D, E, B. This loop, okay? So use the step 5, Kirchhoff's second law. here how many cell do we have? 1, 2. We have only 2 cells. This is 1 and this is 2. So let's go through the EMFs. So for this 8 volt, that means this cell, that's a positive and that's a negative. So this should be the direction. We know the direction of cell is from negative to positive. It always moves through the positive. And our default positive is clockwise, right? Our default positive we have assumed as clockwise. Clockwise means this, right? That's the direction of 8 volt, and it is contradicting our default positive direction, right? This hand is the positive clockwise direction, our assumed positive direction, but the direction of the cell is acting opposite direction, anti-clockwise, right? So that means this 8 volt is not positive cell, it's a negative cell. So let's write -8 plus. We have one more cell, and that's 4. So here, negative to positive, so that's the direction of 4 volt, right? So now, this is our loop, so, and our default positive direction is clockwise. So now, look at this, that's our cell, right? And now, that's our default positive hand. And now, so the direction of cell is acting along the direction of our clockwise direction, along the direction of our hand. So this cell is the positive cell. So 4 is positive. So we are done with the EMF, that means left side. Now look at the right side. How many resistors are here? So here we have 1 and 2. No other resistance. We have 2 resistors here, right? So let's use these 2 resistors. First use this 10. And the current flow through 10 is I2. So 10 I2, try this. Resistance into current. Now we have to figure out the direction of current flow. Here, through this 10, the current flow is I2. That means this is the direction of current flow, right? I2, forget about EMF. We are dealing with the right side. So that's I2. So now, our default, what is our default positive direction? Clockwise, right? Clockwise means this. Now, the direction of our current flow is anti-clockwise. Look, it's acting towards the opposite direction. So, this I2, which is moving through 10, is not acting towards our default positive. So, I2 10 will be negative. Plus, we have another resistance, 2. And the current flow through 2 is again I2. Right? Resistance into current. We have to multiply resistance into current. And through this I2, let's think about the direction. That's the current flow, right? Look, you can see the arrow. That's the current flow. This is the line, and that's I2. So now, if we try to figure out our default positive direction, and that's clockwise. So that's our default positive, right? And I2 is not acting towards our default positive clockwise, right? So I2 through this 2 is not a positive current, it's a negative current. So now simplify this. It's -4 and it is -12 I2. So I2 is equals to, if you cancel both minus, 4 by 12, that means 1 by 3. So we have got I2, 1 by 3 ampere. And we know, what about I3 from equation 1? That I3 is equals to I1 plus I2. So as we have got I1 and I2, we can easily got I3. So by the help of Kirchhoff's law, we are able to get the current flow through this equation. Okay? So that's the end of today's lecture. I hope you understand it. Now I will give you an SW. Please solve it. And if you have any problem, then comment me and let me know you have a problem. Next day we will solve another multiple problem. Solve this and share it. And please stay in your home, stay safe, and see you tomorrow. Okay? Allah Hafiz.